Okay, so particle P is projected vertically downwards. Initial speed there from point A, which is 5 meters above. So we've got A here above the ground, and it's projected down there. That's going to be at 3.5 meters per second. And the whole distance is 5 meters. Sometimes it's worth making a little sketch to make sure we know what we're talking about. Find the speed of P immediately before it strikes the ground. Well, this is going to have constant acceleration, so I can use the equations for constant acceleration, or STUVA, or whatever letters you want to use. Don't have to use it. Distance 5 meters. I put an arrow there, so that's going to be my positive, so it means that 9.8 will be my acceleration. Initial speed is 3.5, and I want to find the speed immediately before it strikes the ground. That's what I want to find. Don't care about t. So the formula without t in there, and so that is v squared equals u squared plus 2as. So I have v squared equals 3.5 squared plus 2 times 9.8 times by 5. V squared equals 110.25, so V equals 10.5 meters per second. After striking the ground, the P rebounds and moves vertically upwards, so P is going to hit the ground and then go vertically upwards, and after 0.8 seconds it passes through, so it's going to go through here, and that's going to be 0.8 seconds. So constant acceleration now, so I've got still going to have STUVA, and I'm going to take up to be positive, and therefore my acceleration is going to be minus 9.8. The distance is still 5, and it's gone 5 in upwards, and t is 0.87, and I've got to calculate the speed it leaves the ground, so I've got to calculate what u is. Don't care about that, and so I need the formula without a v in it, and that's s equals ut plus a half at squared. So 5 equals 0.87 u minus half of a is 4.9, and times by t squared 0.87 squared, and that gives me that u equals 10.0101. It's not recurring, but it gives me that. And it's given the mass is 0.2 kilograms. Calculate the change in momentum as a result of its collision with the ground. So I do it here. Change in momentum equals the final momentum minus the initial momentum. And I know I've got to be careful here because direction matters. Momentum is mass times velocity. So the final momentum is going to be the mass 0.2 times by the velocity, and that's the final velocity. That's the velocity it leaves the ground with. That's what I've just worked out. It's 10.0101, and then I've got to take away, and I'm taking upwards to be positive, and so I've got to take away the mass, which is 0.2 times the velocity, and the velocity here, it was what the speed with which it struck the ground, that's 10.5, but that's going down, so that's minus 10.5, and that gives me that equals 4.102025, which equals 4.1023 significant figures. You could put the units, it's mass, so it's kilograms, and times by velocity, so it's meters per second. And that'll be question 1 done.